All right, so today we're talking about two forms. We're talking about standard form and slope-intercept form. Okay, we are overall talking about this topic in this chapter. We are really trying to emphasize, really trying to emphasize linear equations. What shape do linear equations have on a graph? A line. So both of these forms are going to get me what kind of shape? A line. One of these forms is going to give me that line very, very easily. How many of you, when you've been doing the tables, you know how you had your three values that you had to pick? How many of you find that a little bit like time consuming to make a table? Anyone? Yep, good. What about when I gave you 5 values? How many of you found that time consuming? How many of you are done with tables? Like you wish you didn't have to do those anymore? Because if you don't mind, I'll keep doing it. Okay, good. There you go, Hudson. So I'm going to see if there's a way to find out how to do those graphs without a big table. So what we're going to do is we're going to look at standard form first, and then we'll get into slope-intercept form. So first thing I want you to get, we're going to talk a little bit about standard form. And then we'll see how that relates to slope-intercept, slope-intercept to the graph. Okay, standard form has to look like this. Has to look like AX plus BY equals C. That's what it's going to look like. AX plus BY equals C. It's an equation. How do I know it's an equation automatically? It has an equal sign. Equation. Okay, and then you notice that you have all these letters, and it kind of looks confusing, but let me clarify some things. So write this down. A, B, and C are all numbers. Okay, they're some number that I don't know right now, but there are going to be numbers. And for us, these numbers are integers. Integers. Who remembers what an integer is? And if you don't remember, it's going to make your life very difficult when you work these problems out.
Any number that's positive or negative?
Okay, very close, because technically rational numbers are positive and negative, but I think I know I know what Philip's thinking, but let's say it. Drew?
Whole number and its opposite.
Whole numbers and their opposites. So what's a whole number? 1, 10, 15, 50. What are the opposites of those? Negative 10, negative 50. But what about 0? Is that a whole number? Yes. What's the opposite of 0? 0. So that's also an integer. So those are A, B, and C. And then another thing here, super picky, by the way, on this form. A and B, and this I have to write with words because it's confusing if I don't, are both not 0. Are both not 0. Does anyone know what that means? Because I'm trying to say it as clearly as I can. Yes, sir.
Like A and B can't be 0?
Close. Sophie?
Only one of them can be 0?
Yeah, one can be 0, the other one can be 0, but what can they not both be? These two numbers cannot both be 0, or it's no longer in standard form. So that's what I mean. Does that make sense? Both of them at the same time cannot be 0. Can C be 0?
No.
Good question. Yeah, it's kind of, I was like, well, what does C have to be? So can C be 0?
Yeah.
Yes. Can C be negative?
Yes.
How do you know that? Because C can be an integer. Can A and C both be 0?
Yes.
Both? Yeah. What cannot be 0 at the same time? A and B. All right, you got that. Let's look at an example here. I'm going to add a screen. Let's go with 4x plus 2y equals 8. So write that down, please. 4x plus 2y equals 8. All right. Who can identify what A equals? Who can identify what A equals in this equation? Yes, sir?
4?
It's 4. How do you know that A was 4? It's the first number, good. And a little bit more than that, it's the number in front of x. So what number's in front of x? 4. Or what number's being multiplied by x, you can say. All right, you can tell me what B is. Matthew? 2. How do I know B is 2, Natalie? I like the council decision there. Sorry?
Has it come before Y?
Yeah, it's right next to Y. And then somebody tell me what C is. Michelle? 8. And you know why it's 8? Because it's a number all by itself. It's just that constant. By the way, C is constant. That's what we get. Can you guys identify those parts? Okay, I'm going to give you another one, see if you can identify it. Okay, here it goes. Okay. Negative y plus 5x equals 10. Okay, so you write that down. And my first question, is that in standard form? So you're like, I don't know what you're asking. Is it in that form? Why not? Looks pretty good to me. Go ahead. What has to come first? The x value, then the y value, and then all by itself has to be some number. Okay, so, but it's really close. How do I change that? How many terms are up here, by the way, on this side? How many terms right here? 2. 1, 2. How can I rearrange those terms while keeping it the same value, like not changing things? 5x minus y equals 10. All right, Sam, what's A? 5. Josiah, what's B? Wait, wasn't that plus B? But what do we have right here?
Plus negative b 0 y.
Nice. Okay, what does subtracting something also mean in addition?
Addition.
Adding the opposite. So isn't this negative 1? Very good. Was that you, William? Yes. Or Josiah, you gave me, and then you gave me the explanation. Good job, guys. And Gracie, what's C? 10. Now, did I see it? I mean, I don't know if you guys saw it. Maybe you did, but did I see it immediately at the beginning? Maybe, maybe not. How did I get it down firm? When I wrote it in the correct format. Okay? How many of you can maybe write in the correct format and then identify the A, B, and C? Okay, good, because I'm going to test you out here. On page 1, I'm just going to give you this problem. Okay, here we go. Y equals 3x plus 5. Get that in standard form and identify the A, B, and C. You may begin. What? Okay. Do you remember in standard form, what has to be technically by itself? C, yeah, the C value. And you're like, well, how do you know which one's a C? It's the one without the variable. What's the only one without a variable? 5. That has to be by itself. So what do you think you should do? 5 and okay, you can switch 5 and Y, but how do you do that? Okay, so you like just kind of make it look different, but if you do that, you might change the value. You might change it to a different equation. Here's what I would do. Basically, I'm thinking the 5 has to be by itself, and don't the x and y have to be on one side? So here's what I'm going to do. I'm just going to subtract 3x from both sides. Why would I do that? Well, what's happening to 5 here? It's being added with 3x. What undoes the addition of 3x? Subtracting of 3x, but this is what I'm left with. Negative 3x plus y equals 5. All right, someone give me what's A. Negative 3. What's B? Positive 1. What's C? 5. Okay, there you go. being able to rearrange an equation helps you out. And then getting it from standard form or from a non-standard form to something else helps out. Man. How many of you kind of understand this? Could maybe do this sometime very soon? Okay, good. Let's move on. Let's look at slope-intercept form. Go ahead and write that. Slope-intercept form. And I'm going to do this. I'm going to make this lesson more about slope-intercept form. So I kind of gave you an introduction to standard, but I really want you to get this right here. This is the most helpful right here. So slope-intercept form. And the general form for slope-intercept form is right here. Y equals mx plus b. That's what we're going to call it at slope-intercept form. And one of my goals for you guys, I think it's number 45, is to help you to know that slope-intercept form is your favorite form. You're like, no, it's not. Yes, it is. In fact, from here on out, almost every class you take for graphing and geometry and algebra and stuff, you're going to use this format, and it's going to be really nice. But I don't know anything about it yet because we haven't seen it. So what do you notice about slope-intercept form? What variable is all by itself? The y, right? And then you got this mx and then you got this b there. Okay. I'm looking at it thinking, fine. I don't know what that means, but let's see if we can figure it out. You need to know these two parts right here, what m and b stand for. Okay, m stands for the, I've seen that before, the slope. And do you guys remember what slope is? Good. Rise. So I'm going to put another equal sign. Rise over run. And do you remember that equation that gives us the rise over run if I didn't have the slope? Y sub 2 minus y sub 1 equals, or over x sub 2 minus x sub 1. Good. So we're going to just keep it like that. Keep it simple. And then the b. It stands for the y. Do you remember this a couple days ago? Y-intercept. In fact, now that I look at this right here, why do you think we call it slope-intercept form? Because it gives us our slope and our y-intercept. Do I see the x-intercept anywhere here? No, we're not looking at the x-intercept, only the y. Here we go. This is what you need to know. Everyone have this? I'm going to move on. So y equals mx plus b. Yeah, let's look at this. Write this down. Okay. Jack, is this in slope-intercept form?
No.
Okay. What's throwing you off? What's maybe causing you to think, nope, can't be it?
There's no M or B.
Okay, yeah, there's no M or B, right? But what does the M stand for according to the last slide?
Rise over run and B, more slope.
Slope, right? M stands for slope. And what does B stand for according to that last slide? The y-intercept. This right here is in slope-intercept form. Can anyone tell me what the slope is? What is the slope? 1/3. Good. 1/3. That's the slope. It's right there. 1/3. It's the number that's multiplied by x. If you need to remember that, the number multiplied by x. Right there. Is 3b multiplied by x? No. 1/3 is. That's your slope. What is the y? And you can abbreviate INT. What's the y-intercept according to that equation? What's the y-intercept? Jackson, do you know? It's okay. Sophie, do you know what the y-intercept is according to that equation? Take a guess. It's a number.
3.
3. It's the number you can think of it, it's a number without a variable. Yeah, it's a number without a variable. Okay, you're like, standard form, ax is by equals c, blah, 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 slope-intercept, all this stuff. Okay, why do we learn this form? I'm going to give it to you right now. How many of you are done with the tables? You don't like them? Because, again, if you do like them, I don't mind giving them to you. But how many of you are done with the tables? Okay. we're not going to draw a table, but we are going to do the graph, and we're going to do the graph very, very quickly. Okay, so go ahead and draw your coordinate plane. And I'm drawing it like this. I'm going to draw where the y-axis is a little bit more positive, and this is not as apparent. And just go like, I don't know, like 5 each direction, except for this one, go maybe a few more. I'll go 6. Okay, and there's no like, you must do it this many, this way. It's just whatever's convenient. It doesn't take up too much space. Okay, ready? Who can tell me what the Y-intercept stands for? Does anyone know what the Y-intercept is? It didn't catch you guys. It caught like your hair. So if you had a bad hair day, I'm sorry. But no one knows. How many of you remember what the Y-intercept is? What's a Y-intercept? Ooh, man, it's been 2 days. I mean, I guess that's long. Andrew?
Where the line crosses the y-axis.
Very good. It's where that line crosses the y-axis. So where does this line cross the y-axis?
0, 3.
Okay, at 0, 3. At positive 3. 1, 2, 3. You know, I know there's a point right there, so you draw a point. It's positive 3 on the y-axis. Okay? Great. I know something else about this graph without having to draw anything. Do you notice that the slope is positive? What does that mean? Left to right, it has to go up. And does anyone know how steep it should go? Remember, kind of steep, a lot. How do I know exactly how steep it goes? Yes, sir?
Up 1 over 3.
Do you guys remember what slope meant? Rise over run. What's the rise? 1. What's the run? Okay, ready? So watch what we're going to do. Put your pencil on that positive 3 on the y-axis. Put your point pencil or pen, hopefully it's just a pencil, and go up 1, and then 3 to the right. Put a dot right there. How many points do you need to have a line? 2. You can go ahead. Yeah, at least 2. Good. I'm going to go ahead and draw my line. You go and do the same. That's your line. You're done. Where's the table? Gone. Don't need it. I like the table because it helps you see relationships more, but when you're just trying to graph a line, all you need is the slope and the y-intercept. Now, I'm a little... Some of you think differently, and it's good, but some of you are thinking this, Mr. A, okay, I get 1/3, but what about 2/6? Does anyone know what 2/6 is worth?
1/3.
Okay, ready? Watch what I'm going to do with this little guy right here and this marker. Ready? I'm not going to go up 1 over 3. I'm going to go up 2 over... So up 1, 2, 1, 2, 3, 4, 5, 6. What do I get? It's on the line again. Because what is 1/3 also worth? 2/6. But some of you are thinking of this differently, and I want you to see if you guys get it. You know what? You know 1/3 also, what 1/3 also stands for? He likes your class. I don't know. Okay. Do you know what it also equals? Ready? -1 over -3. Is that true? Is -1 over -3 also 1/3? I really hope so. Okay, ready? I'm going to go from here. I'm going to go down 1 over 3 to the 1, 2, 3. No matter how I take that fraction, what am I always going to get? On that line. You can do it from any point, and you can go for any direction, and you should be able to get on that line because this is what we call a ratio. And I hope you get that. What if I went up 100? Where would I go to get on this line? If I went up 100, where would I go and I'd still get on that line?
300.
I go over 300. Good luck with that. What if I went down 10? Where would I go from there to get on that line? Over to the left 30. And I would get on that line. That would be true for any ratio or any fraction that equals 1/3. Okay, so that's my line. How many of you kind of get this maybe? Sort of? Could do this on here. Okay, we'll practice some more. So we'll stay with me. Okay, go ahead and write this equation down. Oh, wait. That's not slope-intercept form, is it? What form is it? Standard form. I didn't teach you how to graph from standard form. I'm so sorry. What can you do to make it into slope-intercept form? What is by itself in slope-intercept form?
C.
In slope-intercept form. In slope-intercept form. We'll get there. In slope-intercept form. Someone said it a couple of years. Y is by itself. Is Y by itself right now?
Yes.
Is Y by itself on one side of the equation? Yes, it is by itself with it only has a 1, but it's not by, I keep looking at so don't go anywhere. So, does anyone know how to get Y by itself? Yes, sir?
Subtract 4x.
Okay, do you notice that Y is being added with 4x? How do you undo the addition of 4x? Subtracting 4x, and that's what you do. So I'm going to subtract 4x, and I hope you did too. What's 4x minus 4x? 0. I get Y by itself. How do I write this? Are these, by the way, like terms, or I just combine them? Put them together as one? Nope, they're not like.
It's the ghost.
Alex, if you dare, can you close that door? And just lift up that little, do you know that little lever on the side? Yeah, make sure, and it's the air, because it didn't latch. See if it closes before you, I think it might be the other way.
Pull it up. No, pull it up.
Make it go vertical. There you go. And then close it, make sure it there you go. I hope it works. I hope it works, Alex. Hope you have the magic touch. Okay, these are not like terms, but I have to write in a certain way to get slope-intercept form. Does anyone know how to write it? Slope-intercept form. Should I do 5 minus 4x? What's the other option?
5.
Negative 4x plus 5. That's the other option. That's the only option. What sign does 5 have? Positive. What sign does 4x have? Negative. Is that still true here? So we wrote it the same way. All right, Henry, what is the slope of that line?
5.
Close, you're getting there. You got it. Say it.
Negative 4.
-4. And how can I write that as rise over run? How can I do that? So that's -4, but I could say over 1. So if that helps some of you, that's fine. What's the y-intercept? Anna Grace, a y-intercept. What's the b value?
I don't know.
No, you were going to say it. I saw it. It was coming out. We already used -4, so what's the other value? 5. It's the number by itself. That's the y-intercept. How do you know what's the slope? It's the number being multiplied by x. So that's, if you need that to keep track of it, fine. All right, are we able to graph it now? Yes. Go ahead and draw a graph, but I want you to do this before you draw the graph. How high am I going to go on the y-axis, you think? How high do I need to go? Probably like 5. How far do I need to go down? 4? Okay. Because of that slope. Okay, so use that to picture your graph so you don't take up all the space. So I'm just going to do that. It's about an even graph right there. Just go 5 every direction. That should be fine. Hudson, I don't know much about this graph except for one point. I know it off the top of my head. Where is this graph going to cross that y-axis? How do you know 5? There you go. The y-intercept is 5, so it crosses on the y-axis 1, 2, 3, 4, 5. Right about there. That's the y-intercept. You know that point's on there. It's the y-intercept. It has to. Okay. I need to get at least one more point. What's going to help me to get that one more point? Alex? Slope. And what's the slope? What's the rise over the run here? So someone help me out. How do I get to that negative 4 over 1? Like, how do I do that? Yes, sir? To the...
Right.
Okay, 1.
2.
Gotcha. 1, 2, 3, 4. 1, 2, 3, 4 over to the right one. Is that where the other point goes? And I'm wondering, I'm thinking to myself, I don't know. What's your slope? What's your slope? Negative 4. What do I know about this graph? It has to go down. And does it go down now? Yes, it does. Okay. Can I ask you another question here? I'm going to ask Josiah. No pressure, but you got to get this right. I don't think it's negative 1 over, or negative 4 over 1. I'm confused. I really think it's 4 over negative 1. Oh, he gave me a whoa, nice. Thumbs up. Hagen, he says that was good. So do you trust him? Yeah. Okay, good. From this point, Hagen, how do I get up to, how do I go up 4 over to the left 4? How do I do it? Like, tell me what to do. Go. 1, 2, 3, 4. So I'm imagining it keeps going. You mean right there? Is it going to connect with that line? So could I have done that? Yes. Now some of you are thinking, why would you try to do that? Why don't you just do it that way? Okay, if I didn't have space, I may not want to keep going this way. Maybe I don't have space on one side or the other. You can go any way as long as you're coming up with a ratio that's equal to the original. And that's it. All right, I'll have you do one on your own. I'll check it out. Here is the equation for you guys. Yeah, this is a good one. Y equals negative 3/4 x plus 1. So I'll let you guys work on that one for a bit. I want to see your graph at the end. So that's what I'm checking. Okay, I'm going to call 5 of you up, not all at once, but one at a time. You're going to give me different parts of this graph. And you may or may not be recorded. Okay, first volunteer is going to be Brad. Please go up there and give me the slope. Just write m equals blah, whatever the slope is, whenever you want. And then I'll have Matthew give me the y-intercept. So you'll put y-int equals blah, whatever it is. And then I'm going to have Jackson. You're going to draw me the graph. Please do it neatly. Yours is really important, by the way, because if you do it in a sloppy way, then we're all kind of messed up. And then I want Jack to graph the y-intercept on the graph. You're going to use the y-intercept to put it on the graph. And then you go ahead.
What am I doing?
You're doing the slope. You write m equals whatever the slope is. Matthew's the y-intercept. And then I'll go with Hagen. You're going to use the slope after Jack gets the y-intercept on the graph. All right, Jackson, please help me out here. I guess I should say help your classmates. Oh, very nice. Good technique right there.
Could you use a special line
You can, but I want him to try this. All right. Yes. Okay, thank you, Jack. And then I need someone to connect the dots without using the line function. Philip. So Hagen, you went down and over to the right, but did you go down? Well, there you go. And so thankfully it's not going to be too much of a difference, but there you go. Okay. So we'll put it at the same spot. Yeah, that's cool. That's cool. No, you're good. You're good. Give it to Philip. Thank you. And Philip, connect the correct dots. Oh, without the line function. No. You connect it. Just click on the little pen. There you go. No pressure, but this is really hot. Oh, nice. Oh, it's not that easy, is it? All right. That's not bad. I've seen worse. I've done worse, Philip.
I am worse, Philip.
Okay, let's see here. Did they get the right Y-intercept? Yeah, it's positive 1. Did they get the right slope? Yep. And they graphed it, and then they went down 1, 2, 3 over 1, 2, 3, 4. So they got this point connected 2 dots. Got it. Yes, sir? Okay, that's all right. I'm going to do this. I need 15 volunteers. Please raise your hand. I'll just give you a number. All right, 1, 2, 3, 4, 5. You're a group. 1, 2, 3, 4, 5. That's the first group. All right, second group. I'm going to give you 1, 2, 3, 4, 5. So this is second group. Don't mix yourself up. 1, 2, 3. Need 2 more. Yes, 4, 5. Hudson. So 4, 5. All right, that's the second group. Third group. If you can't volunteer, I'll volunteer you. Voice up. 1, 2, 3, 4, 5. Okay, first group, you're going to come up here, and I'll give you a graph to put up here. Second group, you're going to do on this whiteboard. I'll erase this in just a moment. And third group, guess where you're going?
Back there.
Sorry, Mary, they're going to be in your area there. Okay, first group, come on up. You're doing this one, and you can write at the same time. Just don't mess each other up or the board. Most importantly, the board. And you guys divide yourselves up. Each one of you must do one part. So you can do any part. Just do one part.
I'll get the Z.
I'll
I'll get the Y.
I'll drop it down.
I'll get the Y.
I'm going to give you guys a tough one, all right? Y equals negative 2x. All right. Second group, come up to the whiteboard here.
I'll do the Y because I'm 0. The Y-intercept
I'm drawing the line.
Hey, are you in group 2 and I called you in 5? Guys,
I'm going to give you a hard one, guys.
I'm good at drawing lines, so I'm doing this.
Every one of you must do one part at least. And third group, you're in the back. And you can go ahead and get started. They're just going to graph up here, so they might be in your way a little bit. Grayson, do you mind if I come through? I'm going to write the problem up there. No, you're okay. All right, you guys get a very difficult one.
And then no.
And if you need help, ask me. Each one of you must do at least one part. You might have to do 2 parts.
Okay.
Whoever's not in a group, you can be judges. I'm going to ask you two. Hello. I'm going to ask you two if they're right or wrong. going to ask you two if they're correct or not. And then Lana and Natalie, you're going to tell me if those two are right. You cannot help them until the end. Don't talk to them. Don't help them.
It is.
Goodbye, Sylvia.